So for number 1, this line is given to me in slope-intercept form. So what I want to do first is I want to go ahead and graph my intercept, which is -2. And then my slope is 4, which is the same thing as 4 over 1. So I'm going to go up 4 over 1 and put a point. Now that I have my 2 points, I'm going to go ahead and connect them. For number 2, I need to get it in slope-intercept form, or I can use point slope, or not point slope. I can just use the intercepts to find it. Since I have 5 and 3, it's not going to be a whole number intercepts, so what I'm actually going to do is I'm going to go ahead and get it into slope slope-intercept form. So I have y equals -5x plus 3. +3 is my y-intercept this time. Then I'm going to go down 5 squares over 1. And then I want to connect my points. Number 2 gives me a line and it wants me to find the x and y intercepts. So it's crossing here and here. On the y-axis, it's crossing at the x value is 0, and it's going down 1. For my x-intercept, it's crossing at +3, and it's not going up any, so it's at 0. Number 3 wants me to find the x-intercept and the y-intercept of the line 3x plus 2y equals 12. So to find the x-intercept, I'm going to plug in 0 for y. And then I have 3x plus 0 equals 12. 3x equals 12. Divide by 3. X equals 4 for my x-intercept. Then I'm going to go do the same thing for my y, except this time I'm going to plug in 0 for x. Okay. Then I end up with, 3, 0. And then that can be rewritten as 2y equals 12. Okay. Then what I want to do next is I want to divide everything by 2. Just 2. And I get y equals 6 for my y-intercept. Okay. Number 4 wants me to find the slope of the line that's been graphed below. So I am going to draw a slope triangle. It's going up to right 3. You always write rise over run. So I'm going to have 2 over 3 for my slope. Number 5 wants me to find the slope of the line passing through those 2 points. Remember, my slope formula is m equals y2 minus y1 over x2 minus x1. Then what I want to do is I want to label my points. This is going to be x1, y1, x2, y2. I'm going to plug into the formula. So I have -3 minus 5 over 6 minus 4. -3 minus 5 is -8. 6 minus 4 is 2. I can divide -8 by +2. This gives me -4. This one just wanted the slope. So I am good. Okay. Moving on. This gives me 3 sets of lines, And part A wants me just to find the slope of each line. So I'm going to do line 1. This is going to be x1, y1, x2, y2. I'm going to plug it in. I have 4 minus 5 on the top, 3 minus 0 on the bottom. 4 minus 5 gives me negative 1. 3 minus 0 gives me 3. I can't simplify any further, so my slope is negative 1/3. Okay. I'm going to go ahead and do the same thing for line 2. I'm going to keep these the whole way down, so this is all going to be my x1s, y1s, x2s, y2s. So I have 5 minus 0 on the top, 2 minus 0 on the bottom, which just gives me 5 halves. Then I'm going to do the same thing for line 3. I have 0 minus 1, 2 minus negative 1. Remember, when I put it in the formula and there's already a negative, I have to have the double negative so I get the signs correct. 0 minus 1 is negative 1. 2 minus negative 1 is the same thing as saying 2 plus 1. So I have this over 3. Okay. B wants me to decide if each pair of lines are parallel, perpendicular, or neither. So if I look at line 1 and 2, they have completely different numbers in their fractions, so this one is neither. Line 1 and 3, they are exactly the same. That means they are parallel. And 2 and 3, different numbers, so they're neither. Remember, parallel is same. Perpendicular is opposite reciprocal slopes. So opposite sign, opposite fraction. And then neither is just random. Okay. Number 7 wants me to decide if these are positive, negative, 0, or undefined. Straight up and down is undefined. The more right it goes, the more up it goes, so it's positive. It's like reading a book, you always go from left to right. On C, it's straight across, so that has a 0 slope, because it's not changing, it's constant and flat. And then D is going down, so this one is negative. Number 3 wants me to graph the line with a slope of 1/3 and a y-intercept of 4. So I'm going to start with my y-intercept. And since I know my slope, I'm going to go down 1 over 3. And then I just connect my 2 points. Okay. Once I have that graphed, I am good. On number 9, it wants me to graph the line with a slope of -2 passing through the point -3, 2. So on this one, I start with the point that I'm given. I go left 3, up 2. Then since my slope is -2, this is over a secant 1. So it means I go down 2, right 1. And then I want to connect my 2 points. Moving on, this one wants me to graph the line y minus 2 equals 1/2 x plus 4. So this one is in point slope form. So this is telling me I have opposite the sign for my x part, opposite the sign for my y part. This is the point it's going through. My slope is 1/2. So I'm going to plot the point -4, +2. And then my slope is 1/2, so I go up 1 over 2. Then I just connect my 2 points. On this one, if I absolutely got stuck, I could put it back into y-intercept form and graph it from there. Okay. Number 11 wants me to consider the line y equals 3x minus 5. It wants me to find the equation of the line that's parallel to this line and passes through the point 6, 2. So to be parallel, that means I have a slope of 3. 6, 2 is going to be my x and y. I'm going to plug into the formula y equals mx plus b. I have 2 equals 3 times 6 plus b. When I'm working with parallel and perpendicular lines, I ignore the number at the end. Okay. 3 times 6 is 18. Then I subtract 18 on both sides. I get b equals negative 16. I just need to plug back in m and b for my equation to get my new line. I have y equals 3x minus 16. B wants me to do perpendicular, so what I do is, remember 3 is secretly over a 1. So what I do is I flip this fraction, I turn it into 1/3, and since it was positive, I make it negative. Okay. This one's still passing through the same point, x, y. So I plug it in. I have 2 equals negative 1/3, 6 plus b. Then I want to multiply negative 1/3 times 6. I can do the same thing. It's the same thing as multiplying, or not multiplying, by dividing 6 by negative 3. So I have 2 equals negative 2 plus b. I want to add 2 to both sides, and I get b equals 4. Then I plug back in m and b to get the equation of my line. I have y equals negative 1/3 x plus 4. Okay. 12 gives me this graph. It wants me to give the x-intercepts and the y-intercepts of the graph. So I can see it's crossing here, here, and here. So I'm going to start with my x-intercepts. This one is crossing at negative 3, 0. This one is crossing at 1, 0. My y-intercept, I need to be careful of the scale. Each line is counting by 2. So when I'm in the middle right here, it's actually negative 3. And the 0 comes first. Okay. Number 13 wants me to state what kind of symmetries are happening. X-axis means it reflects across the x-axis. Y-axis means it reflects across the y-axis. Origin means it rotates 180 degrees. And none of them means it's not symmetric. So if I take a look at A, if I folded the paper in half right here, it would lay on top of itself. This one is symmetric across the y-axis. This one, it's kind of hard to see. So take a look at this picture. And if I spin it 180 degrees, it looks exactly the same. So this one is symmetric around the origin. This one, I can fold it in half over the y-axis, and it's the same. I can fold it over the x-axis, and it's the same. And then because this is a circle, if I spin this around 180 degrees, it still looks the same. So this one is also symmetric across the origin. Okay. This one gives me a graph, and it wants me to give the domain and range in interval notation. So I am going to start with my domain. My domain starts over here and ends here. They both have solid circles, so I'm going to have these square brackets on this one. This point is at negative 4. This one is at 5. For my range, I'll write this with the red pen. It's got a high point here, and its lowest point is right here. It's got a solid dot here, and the line goes through here, so they both have square brackets. This low point is negative 4. the high point is also 5. Okay. Number 15 wants me to use the graph to determine the behavior of the function between the indicated points. Between A and B, it has a positive slope. Between B and C, it's a straight line, so straight across line, so that means it's constant. And between C and D, it's going up, so this one has a positive slope. Okay, number 16 gives me this graph. It wants me to use the graph to find the following, where it has a local minimum and it has a local minimum here and here. That's going to be, this one is -3, 0. This one is +3, and it's down 3 as well. I believe on B I meant to say maximum. I will fix this on your copy. Okay. On that one, it's right here. My maximum is at 0, 5. Okay. On number 17, it wants me to decide if f of 2 is positive. So that means if I look at the function for the x value of 2, is that positive? It's below the x-axis, so the answer is no. For which values of x is the graph greater than 0? So I am going to highlight. It is greater than 0 between, and it's kind of hard to see, but it's in between 0 and 1, so that's 0.5. So I write this with regular parentheses. Nope, that was positive 0.5. Because these values actually are 0, and that's not included in this set of numbers I'm looking at. C is actually looking for which values of x make it 0. So that's my answer, or kind of my answers from above. I have x equals -5 and x equals 0.5. On number 18, it wants us to decide if it's even, odd, or neither. Even reflects across the y-axis. Odd reflects across origin. And then neither either doesn't reflect at all or just is a funky graph. So if I take a look at A, if I flip this paper upside down and look at it again, it's the same shape. So this one is, it rotates around the origin, so it's odd. If I take a look at B, if I fold it across this line and reflect, it's going to look like a W on one side and a V if I do the other side, so it's not even. If I take the paper and I spin it upside down, it does not look the same. It's now a mountain instead of a valley. So this one is neither. Okay, for C and D, I want to use my graphing calculator to see what these look like. So I'm going to go to y equals. I'm going to type in my function. And then I hit graph. Let me check something on my window. There we go. It just wasn't showing my tick marks. Okay, so if I take a look at this graph, it's slightly off center. That means it's not going to fold over nicely on top of itself. And it's U-shaped, so when I flip it upside down, it doesn't look the same. This one is also neither. I can do the same thing for D. So if I type that in my calculator, I have 3x cubed. And I go to graph. So this one is curvy, and if I look at it, it looks like it might be origin symmetry. And if I rotate it around, it does look the same. So this one is odd. Okay. Number 19 wants me to find the average rate of change from g of x equals negative 3x cubed plus 5x squared between the points x equals negative 2 and the point x equals 1. So what I first want to do is I want to plug in those points. I have g of negative 2. Means I replace all my x's with that negative 2. That one was cubed. Okay. If I want, I can type this exactly into my graphing calculator, and it will do the math for me. I just need to be careful with my signs. I want to make sure when I have a negative number, I'm using the negative down here. So I have negative 3 times negative 2 cubed plus, oops, got an arrow out of there, plus 5 times negative 2 squared. If I press enter, I did my, oh, oops, I forgot to delete the plus. Okay. And I press enter, it gives me 44. Okay, then I want to do, I'm going to rewrite that this was g of negative 2 so I don't forget. And I'm going to go ahead and do the same thing for g of 1. Okay, I'm going to type this in the calculator. I always forget the newer ones write it straight in line. So if you're on an older one, it takes you out as soon as you type this. If you're on a newer one, it doesn't. Plus 5 times 1 squared. This one gives me 2. So really, this is saying I have the coordinate points negative 2, 44, and 1, 2. Finding average rate of change is similar to finding slope. What we do here is we are going to label them x1 and y1, x2 and y2, and then I just plug into like I would for the slope formula. So I have 2 minus 44 on the top, 1 minus negative 2 on the bottom. 2 minus 44 is negative 42. 1 minus 2 is 3, because it turns the double negative into a positive. I do not know negative 42 divided by 3 off the top of my head. It gives me negative 14.